Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 69th Project Euler problem. As always, I will link to both the problem and my repository in the description. Let's dive right in. Problem 69 is the totient maximum. Euler's totient function, phi of n, sometimes called the phi function, is defined as the number of positive integers not exceeding n which are relatively prime to n. For example, as 1, 2, 4, 5, 7, and 8 are all less than or equal to 9 and relatively prime to 9, phi of 9 equals 6. And then they have this table listing all of the relative prime numbers. It can be seen that n equals 6 produces a maximum n divided by phi of n for n less than or equal to 10. Find the value of n less than or equal to 1 million, for which n divided by phi of n is a maximum. So, even just this small sample size, we can see that certain numbers have far, far more relatively prime than others. And I actually ended up having to look up what relatively prime means when I first was examining this problem. It is a number is relatively prime to a larger number if they do not share any factors. So for instance, an odd number will always have every even number lower than it being relatively prime. So as we can see, the number, the highest possible n divided by phi of n here is 6, which is 2 times 3, the smallest two prime numbers. So the naive approach would be to go through literally all of the numbers and find all of the relatively prime factors and calculate out each n divided by phi of n. But there's no way to do that, at least not that I'm aware of, that does not exceed our minute-long time limit. I spent quite a while on that. I have not checked that I found the correct answer, but I think the solution is actually to multiply the prime numbers until we exceed the limit here. And we don't even actually need to calculate this n divided by phi of n. So let's go ahead and program this in. I've already done the boilerplate stuff that I do every problem. And then we're just going to do a little is prime array here. And we're only going to multiply by limit because we don't actually care about the equals to limit. And then index 0 is equal to index 1. It's false. And basically what I'm doing is I'm going to do that sieve of Eurasthenes, or whatever his name was, see. I've done this before. Okay, so a yoink my old code. Okay, so for I in range, starting with 2, all the way through the square root of limit, if it is prime, multiply by itself, and go through and set all of the multiples of it to false. Now, this step may not be strictly speaking necessary, but for our purposes, let's leave it at that. And we're going to do limit equals 10 first, real quick. Okay, so then for n in range, starting with 2 through limit 1. We're going to call this maximum n. I'll set it to 1 because I'm going to be multiplying it. If is prime. n. And then if new max is greater than limit, break. Which should break us out of the entire for loop. Otherwise, maximum n equals the new max. And what we'll do is we will just print and then for limit of 10, this should just work. Okay. We'll add that +1 in there and see if that fixes that. There we go. So for less than 10, found maximum n to be 6. So if we go ahead and bump this, let's see, that's 100,000. That's 1 million. Bump it all the way up to 1 million. And this is going to be extremely fast, I think. Let's just see how long it takes. Okay, so that was effectively instant. We got this 510510. Let's see if it's the correct answer. And it is. Okay, so yeah, the key insight here is when you multiply the prime numbers together, that's going to end up with the number that has the fewest relatively prime numbers below it. Because whenever you have an odd number, then all even numbers are relatively prime to it. And like here in 10, we have like all of these odd numbers that are relatively prime to it. But if you multiply like the prime values together, then it has the fewest relatively prime numbers lower than it, because most numbers below it are either most numbers below it are going to be multiples of primes. um, Obviously not all, like in this case we have the 1 and the 5. I can't say that I know what the relatively prime numbers are for this number. We could calculate that out, but to find this answer we did not need to. So yeah, hopefully that is clear. If you have any questions, please feel free to drop them in the comments below. And if you would like my personal help on any code challenge that you are working on, please check out the link in my description. I've just started offering that as a service. So thanks for watching, and I'll catch you in the next one.